Yes.
Use a diamond problem.
All right, 28 to 33 is your homework. So, go ahead and write out the trinomial first. So, 6x squared plus 17x plus 12. Then we want to think about two different things at the same time. Well, not at the same time. But if we set up, and I'll do it their way today. If we set up our area model, and we have 6x squared and then our constant of 12, we know that our variable is 17x. As we talked about yesterday, it comes from two different products, the sum of two different products. So we know it'll be broken up. So now what do? This is where I want to see if we remember this process. Ava.
So first we set up like the diamond. So that, and then for the sum we put 17x, and then for the product we put 72x squared.
Now wait, where did that come from?
That comes from 6x squared times 12.
Because we know that cross products in our area model have to be equal. It is proportional. So we get 72x squared. So now we know that these two values, the coefficients of them, because we know x and x, that's just going to happen. The coefficients must be factors of 72. And you really hope they're integers. Owen? 8 and 9, do they sum to 17?
Yes.
Yes. So we fill in 8x, 9x, and we can check, will this still hold true? You betcha.
Do you have to do 16 because we did it on our homework?
No. We are going to wrap that lesson here. We're going to bump on to 413. Any questions on this before we move on?
No.
Is this starting to make sense and kind of like, it's kind of cool? I know it's not cool like, whoa cool, but it works. It's math that is effective.
Math is cool. I like it. It's not math, it's magic.
I love
Mathematics.
I don't like when people say that because there's no magic or trickery or anything like that involved. It's just math. All right, so please make sure that we're practicing good note-taking skills. So you want to make sure that every day we have a date, which of course now we are into November, and I woke up to my weather saying wintry mix will continue, and I'm like, what?
Well, it's snowing today, right?
Yeah, kind of. It was spitting snow/rain. And we are now in 4.1.3, working on, if somebody were to ask you, because this is really funny, I actually tutored a student last night, and I was like, so what are you working on right now? I had no idea. And I'm like, oh crap, I don't even know if my students can answer. What are we working on right now?
Quadratics?
Yeah, but we're factoring. The broad category that we're doing is factoring. Now, we are factoring quadratics, or trinomials, if you will. But we are.
We don't put the date, and we just put the
You kind of want to have things dated. You'll understand this more as you get in high school and college. When you're using notes that have come from multiple days or multiple classes, it is nice to know, like, oh, this stuff was all taught together, that stuff was. So it's good to date it. I'm not going to make you do it, but just for note taking, yeah, it's good to have it on there. And then it is like, and this you won't really understand now, but then, you know, a couple years into college, when you look back at a notebook from like college the first year, you're like, oh, this was that day and that day. Like, it is just nice to have it kind of like a journal in a way. Like, oh yeah, that was going on then. And you can relate it back to the date, not just what math you were doing. You know, math is the most important thing in your life. Facetious. Sarcasm.
I really like math.
It's the most important thing in my life. It is fun.
Math is everything.
Okay.
It's occasionally fun.
So, let's have you guys try A through D on your own. Let's see how good your skills are now.
I'd say math is fun.
What's the conventions too, or just the numbers?
95 to 8.
Well, sure if you want. once we fill it all in, it's like we'll get really good at finding the dimensions really quick.
Okay, because I've already filled mine. I just didn't know.
So when we talk about full-on factoring, yes, we need to find the dimensions. So I guess yes, we need the area model dimensions. Mm.
I have noticed that I am getting better at this. I like this method.
It's a good method, but it takes too long to do.
No, it doesn't.
That's cute, Jenny.
What? You really don't even need to do the area model, do you?
This says
Do you use your head?
Okay, on one or on A, no. On D, yeah.
Okay, well, just do
And we'll look at the difference between those.
Okay.
So when we look at the dimensions for our rectangle in A, do we have it yet? What adds to 6 and sums
3x.
or products? 3x?
Basically, it's x squared plus 3x squared.
What? Right? No, it's 3x, 3x.
I think what you're trying to say, Jenny. Oh, why did it separate it like that? That was ugly. I think what you're trying to say is it's really x squared plus 3x plus 3x, not 3x squared, because we got to make 6x, right?
Yeah, yeah.
Plus 9.
Yeah, I think so. Oh, wait, no.
So what are my two here? These are 3x's, but when we look at our dimensions,
Oh my gosh.
when we have x and what and x and what, Chris?
3 and 3.
So we have 3
Oh yeah,
and
it's
x
plus 3 squared,
and
not
x
x squared plus 3.
and 3.
You know what? Just
So the dimensions of your rectangle fill in the factor pieces or the binomial parts that make your trinomial.
hold up. What if this is a prime number?
What do you mean? Do I need to hold up here?
No.
Yeah, okay.
Prime numbers.
So B, I'm going to get it up here and then somebody help me fill in my box for B.
I get it.
So we know the 2x squared and 3.
Yeah, so then you multiply them, and then when you set up your diamond, the 6x squared on top, 5x on the bottom, and then if you multiply 3x times 2x, you get 6x squared. If you add them, you get 5x.
Sweet. So 3x, 2x. And that would mean, okay, so my x's have to be in the corner together. And that means here I'd need to have 3, and over here, wait. So be careful when you have a coefficient to your x squared. My advice would be when you start filling in the dimensions, leave these as just x's till you figure out which one needs the coefficient. Good spot, Gunner. The one on the left needs a 2 because then this needs to be 1, making, hey, make sure we're getting to this point. Make sure we're getting to the point where we're writing out the binomial times the binomial. What are my binomials in B? Yeah, Colin?
X plus 3 times x plus 1.
What equation again?
I'm curious what is going on over here. What are you guys talking about? Well, we're not there yet, so calm down for just a moment. Hey, can you take a breath? Like, you're not breathing with me.
Thank you.
Okay, so do you have this for B?
Yeah.
Can you come back to B with me for a moment? So let me talk about one thing for a second. Now that we're talking about having coefficients to my x's, look at the difference between what we have and if instead, I tried to make my 3 with a 1 up here and a 3 over here. That would still make my 3, right? Would this work? Could I make this work? Well, the first argument would be, well, I need to switch these locations, right? My x and my 2. Well, that won't work, right? So I switch and I put my 2x here and my 3x here. Does that work?
No.
So be careful. All because we can figure out the numbers doesn't mean we know where they go automatically. There's a specific location. The 3 can't be here, even though it will make this 3. This is the mistake I've seen. You're looking at me like, hey, that's dumb. This is the mistake I've seen. This will make the 3. It won't make anything else work. Once the coefficients happen to the x, things get more complicated. So 3, 1, your 3x here, your 2x there. Okay, C, the point of contention for our table over there. C is x squared plus 5x minus, it's not only prime, it's a prime negative. Yeah. So take a breath, calm down, draw the rectangle.
Wait.
Hold on. Did you calm down?
No.
That was step 1.
Clearly not.
So, the x squared value, bottom left, right? We're going to start, I'm just going to give in and do it CPM, even though I don't like putting the heaviest, well, if I say heaviest, then it kind of makes me happier, but the biggest value on the bottom doesn't really make me happy. And then -7, right? What's the product? What's the sum? When we have prime numbers, what's the only way we can get there? 1 in itself, right? So,
Both of them have to have an x, so.
well, okay, so we know x and x.
So one of them has to be 7 and the other has to be 1, and one of them has to be negative.
1 has to be negative. We could put that somewhere if I want.
So would it be -1 and then 7? But that wouldn't equal 5. That's my problem. Yeah, I don't understand. It's not possible.
Is it not possible?
Yeah.
I mean, what do we think?
I don't think it's possible. It doesn't say that not possible is
If we have a prime number here,
it's not possible.
and that is going to be the result of, well, back to what we talked about yesterday, a binomial times a binomial, right? We're going to have some x value and then constant, some x value and then a constant. The lasts, right? I wasn't supposed to talk about, did we talk? No, we didn't talk about FOIL. I did that in my tutoring. Okay, never mind. But, oh, we did? Okay. I'm not supposed to teach it to you yet, right? So, CPM doesn't get to that point yet, and they don't want you to know this, but when we distribute binomial multiplication, that's, yeah, it ends up being FOIL. Sorry to ruin the surprise. This has to make 7. Well, in this case, -7. Which means my only options are 1, -7, or 7, -1. Will that in any way sum to 5?
No.
Not factorable. Not possible. It's really mad.
I'm like, wait, I'm like, why am I having so much trouble on this? I'm like, wait.
See? I told you what's your name, Brian.
You know you're just
Now, here's the thing. All that means is you can't break it down into the binomials, right? It's not binomial times binomial. There's other cases, though, which we'll look at when things get much more complicated.
Okay, I don't think the last one's possible. Wait, where?
Oh, it's possible. 3 squared plus 7 minus 14.
Oh my gosh, I was looking at the other thing. I'm sorry. I'm stupid.
Now the 3 makes this really fun. Now, still luckily, the 3 being prime still only gives it a limited amount of options. like we said yesterday, once that coefficient gets to larger non-prime values, things are going to take a bit longer. Whoa. This seems to get out of hand.
It does.
What? So 14 times 3?
42.
Yeah, that's a problem.
Negative 42 and squared.
Yep, no. Wait,
But we sum to just m.
one.
Now this is really nice.
Wait, do you just
What?
split it in half?
Hold on. So this tells me that my pieces
Have to be next to each other.
have to be next to each other,
One has to be negative.
but one's negative. Which one would be negative then, the stronger or the weaker? The weaker, the smaller one, right? Because this is positive. So if we look, did you get to the point? We don't split it in half.
Is it 22 and then 22?
Remember, this is the product.
22 and
It's the multiply. We don't add to get the 42. We multiply to get the 42. But the factors do have to be one away. One is negative, which is going to be the weaker one. So start thinking about factor pairs. What about 5 and 6, 6 and 7, 7 and 8, 8 and like even?
Negative 6 and 7 works.
Negative 6,
Well,
7.
actually, it's negative.
We know that this is actually how far apart they are. Right? Or if this is positive, it's the sum. But when this is negative, this is how far apart they are.
That's confusing.
Well,
What do you
actually, there's 13.
But cool.
What do you mean it's confusing?
It's not. It's weird.
Well, okay. How? Yes, you know what I mean. The numbers are, because if you did like 8 and negative 6, you get 2m. 8 and 6, 2 away. You know, absolute value distances. I think I'm still like the problem is I learned this. Like I caught on to this well, even though we weren't taught the greatest back then. But like I loved factoring trinomials just because I got decent at it. So when I say things like that, tell me when it doesn't make sense. Like if I say they're 1 away, well no, they're 13 away, but you know what I mean.
Yeah, I just did.
Yeah, no, I got you. All right, 25. This is a very different set of situations. So play with these with your team.
What?
Oh, yeah. This is
Why did you start with the triangle?
because I like it up this side.
Start with a triangle.
It's not a triangle, but I just blended it out. Why does math class always go by so fast?
Wow.
Split it up. You had me working
Wow.
on it.
What do you mean?
Like, break one of the terms into two.
Play with it for a minute.
Hello.
Wait.
Okay, got A.
I mean, it's 3x.
Well, I
3x.
think you have to put
Can we split it smaller, like 1x times 2x?
You love my name.
No, because I don't
Oh, get it.
What?
Oh, I get it now.
Wait, what if the other term is 0?
Okay, so basically what it is,
The other term is 0. It's supposed to wrote it there.
when I
Mr.
like
Hudson,
this,
you need to
and
play.
there's
Now,
two numbers, one of them is
Sneaky
the
liar.
same.
I'm appalled.
You don't get A for as many zeros as we want. Because we call it
Yeah,
like
I
the
get
square.
squared,
The
and
rest
5
perfect squares.
makes it 6x squared.
You always make it up.
The other solve as whose x is 0. Well, just 0 x.
The other
not
two
x
values.
0.
You get, oh, I get, we get,
Yeah, yeah.
Well, if it is 0x, then x is 0, right?
No, it doesn't.
Well,
X is
that's
x.
what
We
the
get what
product
you're
will be.
saying.
Yeah, good.
even if you're not a good
Ben, are you okay, bud?
No.
Is it good?
Okay.
It's 9, so it's not
Oh, hey, I had mail in my back pocket. Were you guys ever going to tell me? I had something to stick out. So,
Wait, that'd be
like,
zero.
how's this
Wait.
what are you doing?
That'd be zero, right?
Yes,
Yeah.
So, with the new, with what we're looking at now, the only difference is the trinomial look like we're used to. We still have a trinomial even though we're missing our B term. We still have a trinomial here even though we're missing our C term. The thing is, those values have turned into zero. It's not that it's not there, it's that it's zero. So if you look up there, I rewrote it saying 9x squared plus 0x minus 4, which just means that when I add those things up, they are additive inverses. Doesn't mean they don't exist, they just cancel each other out.
How do you do that? So it would be, you guys get A, guys?
Yeah. It's a very minor. That's a very thing to find out.
That's what I'm writing.
What is
Alright, let's chat about A before you guys get too deep. Let's chat about A before we get too deep. So, I rewrote this explicitly showing the 0x. Right? We aren't missing that B term. It is just a 0, which we can efficiently not write. So we still can do the same process. Right? We can still set up the same rectangle. We can still set up the same product, but now in the bottom here of my special diamond, or whatever we're calling this, what goes in the bottom? 0x. So these values, what do you mean, what? It's the sum of the...
You can just put 0.
Well, okay, but it is specifically 0x. Calm yourself. You're really worked up today. Did you eat too much candy last night?
No, I didn't.
Sure, we'll say you didn't. So, now, additive inverses make 0, and we have to multiply to make a perfect square. A negative perfect square, but still 36 itself is a perfect square, so we figure out negative 6x and positive 6x to get the job done. Now, hold on. That does not mean, again, mistakes we've seen, that these are 6's. That means these are 6's and negative 6x.
They're 2's. It's plus 2 and negative minus 2.
So remember, that's what you get from the area model. You'd still have to get your dimensions, which will be, crap, I don't have anywhere nice to write them. But one is 3x with a plus 2, and another is 3x with a minus 2. Now, the other option, because again, my coefficient of my x squared is a composite, would have been the x and the 9x. Can you tell me why that's a bad idea? If I set it up like this, the binomial multiplication below there. So this, right, my last, has to be negative 4.
And that doesn't work.
But my outer and my inner multiply with the x values, right? If I tried to use 2 and negative 2 in a situation like this, my outer would be negative 2x, but my inner distribution would be positive 18. It's nowhere close to additive inverses. That's why, if possible, when you see a 0b, you want to try to make these x values match. It'll make things a whole lot easier. And we'll talk specifically about the special name we have for these things later in this chapter. So, B and C and D, anybody having big issues on anything?
Is D not possible?
D's possible. D's is possible.
Rewrite it as negative 1, or like, so, for D, We're not really doing D yet. I'm gonna copy some pages and rewrite it in a different way.
Okay. Alright. I forgot what I did.
That's an n squared. You have to remember that. 0 n squared.
I think I might have been doing this process wrong.
What do you mean?
Like, I haven't been finding the, like, I haven't been finding the dimensions of the square. I'm using the square first, and then the diamond, then I put that.
Yeah, you need to find the dimensions. I said specifically at the beginning of the lesson that the factors are the dimensions. So finding what fills in the squares just leads us to get the dimensions.
Why?
So there's a start on D.
There's multiple processes.
Yeah, there's a lot of processes.
I don't know, check my work. There's an easy way.
Oh, I messed that up.
I won't be bad.
I completely messed
What did
D up.
you get for D?
I didn't.
That's really weird.
Hmm.
No, I messed up.
Oh, that's easy. Okay.
Add up to negative 100.
Wow, it's just negative 100. Okay.
Jenny, you are like the person in the movie that's like, well, guys, it's not like you don't know that order death is him, her, and then him.
I actually not.
Or the death order.
Yeah, you are, Jenny.
I love that graph paper. Can I have some?
Or reinforce them.
Yes. I love those. I get to peel the sticky stuff.
All right, we're going back to B. What?
Well,
I mean, it's kind of obvious. Think about it.
You put the plus 0. What's the fun in that?
You put the lemons and coconut.
Because I think everybody has realized this at that point.
No one's heard that song? Oh my gosh, I went to freaking.
So I'm confused. Now we're like getting rid of terms. Right? So now they've gotten rid of the C term. They made that 0. But that then makes my sum, or sorry, my product, my cross product 0.
So one of them has to be 0.
So one of these has to be 0M. What? So wait, what does that tell me about the situation I'm now working with to get my trinomial, Ava?
This has to be. Well, that means that one of them. I don't know, but the other one has to be negative 16x.
So this one is going to have to be negative 16x because it has to do all of the work summing to the negative 16x.
It has to be.
And then I know, okay, so negative 16x and 0, so we might as well say 0's over here.
Yep.
And then I know x and x, and then I'll figure out my coefficients. I'm going to need to make 16, sorry, negative 16.
You need negative 4 next to it, and then
12 and 1.
So then a
4 and
4x.
3 next to 12x.
Or you could do 12 on the instead of the 3, 1 instead of the 4, and negative 16 instead of the negative 4.
So wait, hold on. Let's start. Wait, what? Let's write some options out. You're telling me there's multiple ways we can do this? So what we have written right now is 3x minus 4, and actually 4x not a binomial.
Plus 0.
Not a binomial.
It's a.
Interessante.
I have to know.
So wait, then you said I could do 12.
12x minus 16 times 1x.
Because now we're just using the distributive property.
Or you can have both the 3x and the 4x negative. And not the negative 4.
Yeah, I'm gonna 4 on it.
So wait, negative
Plus
3x plus 4, negative 4x.
Yeah.
Hmm. Hmm.
No. 2 and
Interesting.
You could do 2.
Okay.
6.
Okay. We're gonna move on. So
Okay, Chris. Yeah.
flaunting now.
Let's just go on forever.
If I reorder C, 8k squared minus 10k plus 3. Ooh, 8. That could factor up with an 8 and a 1, a 2 and a 4, a 4 and a 2, or a 1 and 8. A lot of options to start here. So, let's use the effective process that we know. 8x squared, constant of 3. It's what?
It's just the same thing.
What do you mean just the same thing?
Yeah, that's the one within 24. Yeah.
Oh, it's literally the same.
Decided to move it around.
Okay,
and try to
sweet.
trick us.
Good. Then let's move on. So
Because
D.
we're the casual high school.
You aren't the casual high schoolers. That's why I can teach this differently. This one's weird, right? Jenny, would you like to go ahead and talk about this one?
Just how do you do it? Because it's like.
What you were gonna spoil before.
I mean, really, like, it's not that hard.
I just wanted people to have a moment to try it on their own. If
I
we
thought we already
sum,
went over it.
if we sum to something, but product to nothing,
Then, okay. So, if you product to nothing, obviously there has to be 0. And then if you want to sum to -100, then the other one just has to be -100 because -100 plus nothing equals -100.
we're still not done though. Where do you want me to put my -100 m?
Okay. Oh, shoot, I haven't done that.
Does it matter?
Ah, you haven't done this part yet.
Yeah, okay, so you want it to, like, right there, and then that's a 0, and then what's a 0? Well, I mean, I know.
So, what, 0, and then probably m here.
Yeah,
Wait, 0 m squared. Oh, well, okay, so that doesn't matter.
then what? -100 there. Let me show like this. And then
Wait. That doesn't work.
yeah, no, that doesn't. Okay.
Miss.
Oh, well.
I don't think it's as easy as you thought it was.
No, I didn't think the whole thing was easy. I just thought you were talking about that part.
Like the diamond
Can I
part.
do
Yeah, the
this
diamond
one?
part.
So,
And then
Jenny,
I was like,
hold
it's
up.
not that hard.
Because we're multiplying by 0 here.
But not like the whole.
Because we're multiplying by 0 here. This doesn't really matter, does it? But it does to here.
Yeah.
So let's look at this first.
Yeah,
Can you think of things that will make a product of 40? Chris, chill.
Right? Are you okay?
hyperventilating?
No.
Yeah, he
I
is.
just feel
He's like,
What do you think?
well, maybe.
So like if I put a 20 here,
Okay.
what would have to be my other factor? A 2. If I put a 2 here, then this just has to be -50. And I mean, does that work?
Yeah.
Sweet.
Wait,
Is it my only option?
but I'm
No.
done. Okay.
I did believe
We're not
Wait, but
going
how do you get the? I don't care. There's no. I can percussion. The 0 and
Put
and
it
that
up.
0 and.
Mm-hmm.
I did 40.
This 0m is the product here.
What?
I did
But
40.
how are you
Say
getting
that
the
the
n?
0 is 0.
Because it's just 0. So this is m. Sorry, I should have labeled that. That's 0 m's.
22.
If we want to be technical about it. Because the 0 m squared and the yeah. Sorry, I should have written that there. So now well, it's just 2 times -50m plus 20. Now wait, can't I? So wait, what is this? Well, yeah, but what is this? If I said this, what's my function? Type function. This doesn't exist, right? It's 0, so it doesn't exist.
So it's just what is that?
It's just a linear function. And this, what we talked about yesterday with the solutions being zeros, how many times will a linear function cross the x-axis? Once at max. Right? As long as it has a slope, it's going to cross once. Interesting observations here. All right. We can probably. Are we good on 20? Well, we can. We're running out of time. Let's skip to 27.
Well,
What?
we started doing
27?
No.
26.
Do you want to do 26 or 27?
Both.
Okay, let's do 26 then.
No,
We'll see if we have time.
27 first.
26 might be faster, so. All right, so when we have a negative, I'm going to help you with a couple things here if you care. When we have a negative sum of your x's,
Wait. Hold on. Oh, never mind. I thought you said we were going to 27.
we were, then I got convinced otherwise.
Oh, I got 26 already. Are you proud of me yet? I figured it out. Wow.
You got 26?
Yeah, I got the diamond.
Oh, yeah.
So let's find the factors and stuff,
What goes in the top of the diamond?
Oh, 4 plus. Oh, you did it the other way. Okay. There's 4x squared.
So, if I only knew this was negative, these could both be negative. But since this is negative, what do you want to spoil, Jenny?
I figured it out.
I want to spoil.
Okay, sure.
Negative
Oh,
12x
just take
and
that.
2x. Because obviously it is. I figured it out. Children.
Now, Chris, remember that whole, like, when we have negative, it tells how far the numbers are away? Again, not actually 10 away. But you know what I'm saying. 2 and 12 end up with a sum of 10 because they are fighting against each
Oh,
other.
I figured the rest of it out.
Give it to me.
It's 2x plus 1 times 2x minus 6.
So where's what?
2x is above 4x squared, and then
Because the well, is your rectangle the same way as mine?
I put
What?
2x. No, the 2x in the diamond is above 4x squared.
Oh, this.
Yeah.
Sorry. I thought you
No,
were
that's
giving
still
me the dimensions. And then
It's still there.
It's still there, Mr. Austin. But the 2x's you put in are still there.
They still belong there.
You just go fill it in.
but why couldn't they be 4x and 1x?
Because then that would have to be negative 12x, and that doesn't work.
And this is why this process is more efficient. What I showed you when we just worked backwards into FOIL, we'd still be wondering, can it be 4 and 1 or 1 and 4, or is it the 2 and 2? Here, when we look at the area model, what I hope that you're starting to see is by looking at it, not to use holistically, is like, but when you step back and you say, okay, how does this work together, and you see the grid, it should quickly start to make these connections. So even though it's like, do I really have to draw the rectangle and the it gets you there efficiently.
It really does help. I like this method.
Sweet. Thank you very much. Yeah, probably maybe. Who knows?
Last day
We get as far as we get when we run out of time. Hey, you guys gotta hurry. We went like over, so we gotta get out of here. I'm sorry. My apologies. Low CM2. All of you? All of you. That was terrible. Sorry, you got up. I was expecting the art to happen. Yes, I've been told they're very, very good. The only bad part about candy corn is that it wax.
I will gladly take all the candy corn.
All the candy corn? You like candy corn?
Oh, it does taste like candy.